I'm making a video game with underwater mechanics. In this devlog,
New enemies, updated effects, additional levels, feedback fixes. A while ago, Hooch gave me a suggestion for another enemy type to go with the Kitsal platform, so I worked on implementing that. My first attempt was to use an effector to push the player upward, which worked alright. In order to have the jet stream interact with the Kitsal, my first idea was to check collisions with a box cast. However, I wasn't sure what the parameters on the box cast meant. I found this great video that explained how it worked and used that as a basis to give it a shot. For this first attempt, I used a debug ray to draw a line from the source point to the first collider that hits the box cast. A problem with this method is that the tail of the Kitsal would block the effects of the stream even if the player wasn't on top of it. An alternate approach to the box cast was to use 3 rays to detect what objects collide with the water stream. 1 ray is casted from the middle and 2 others from the edges of the trigger zone, all pointing up. With that working, I refactored the logic to point towards the target point instead of hard-coded to the up direction, so the streams could be rotated and still work. Now that all the detection logic worked correctly, I cleaned up my prototype and made it into a better mono behavior with clean code. Then I tweaked how the jet stream forces interact with multiple chests since I want them to also be affected by the stream. I also updated the chest to be able to stick to a platform, which was feedback I'd gotten about the jellyfish at some point. This caused a funny bug where the chest gets shrunk and immediately detached from the player. This is due to the platform logic removing itself as the parent when the chest leaves the trigger area, stealing control away from the player's item port. I updated the platform-based logic to only remove the parent if it is the parent, otherwise do nothing, which fixes the issue. With that behavior corrected, I tested the interaction between the trap, chest, and player to ensure the platform would block the effects of the force if it was hit first by a ray. Happy with the logic, I proceeded to work on the visual styles. Since it had been a while since I made the particles, I did a bunch of research on the best way to get my bubble effect. I started by reading through this devlog from the Warchur's Defenders about pixel artifacts. During my research, I also ran into this case study by making stuff look good, breaking down an effect from Wind Waker and explaining how each component works. Making stuff look good also had other videos that were really helpful. A suggestion I learned during my research was to break down particle effects from other libraries and explore how they work. So I used some of the cartoon effects particle effects I had to learn how the parameters work. After a lot of work, I had a sample of the bubble with a particle that looked good. With that base, I played with randomizing the colors, sizes, and position of the particle being emitted. Happy with that, I then designed a small base to indicate this is a man-made trap. This first version felt a bit simple and thin, so I used the bubble effect as a base and designed the trap so it frames the area where the bubbles spawn in. Then I imported the base as a sprite and defined the physics shape. I updated the particle system to interact with colliders, so the stream cuts out when the bubbles collide with the trap, player, or chests. Since the player and chest have different mass, I made the trap apply different forces to them and spent a bit nailing down the numbers. The jet stream also has a blocking mechanic, which lets the player cover the spout and avoid the forces. To make it easier to place and scale these, I updated the mono behavior with editor-specific tools that scale the particle effect and move the detection targets based on size. Having learned about particles, I tackled a task I had in the backlog for a long time, remaking the player's bubble effects. The cartoon effects pack I bought a while ago had a good breathing particle, so I started by tweaking its parameters and shape. Then I tweaked the speed and emissions for the particle. The base used a sphere to emit the bubbles. Since I wanted them to come from the head area, I switched the shape to follow a 2D cone. I tried tinting the particle colors a bit and changing the lifetime so they last a little bit longer in the world. Knowing now how some of the parameters work, I was more quickly able to tweak the emission parameters to have a consistent breathing effect that's less hectic. I made a pixel-based texture and applied it to the particle just to see how that felt. I eventually opted to just go with the effect without a pixelized texture. With that effect looking much better, I tackled the hit effect. Like the previous particle effect, I started with the emission and the shape. I also want this particle to come out of the same area as the breathing particle. This did not look good, so I took another approach and tweaked the CFX hit bubble effect parameter. For consistency, I used the same colors as the breathing effect. I did make the hit particle ranges bigger so it is more noticeable. Some of the movement patterns for enemies I haven't explored are rotation and zigzag pathing, so I worked on making an enemy that did both. I started by creating an endless rotation loop using the lean tween rotate C function, which didn't work. I looked at the GitHub issues and the developer suggestion worked. Here's how that looked with the updated suggestion. Since the crab patrol logic goes between points and accounted for diagonals, I played with using it to form a zigzag pattern. I started by using a diagonal line and seeing how that worked. I upgraded the gizmo buttons to allow me to lay out the points in a zigzag pattern based on a vector to more easily lay these enemies out. When I first made the temple spear, I arranged them in a star pattern with the intention to make a circular-based enemy within it, so I spent some time in Aseprite making that enemy. I had two variations of the spears, so I set up their physics shape, leaving space for the trigger collider. Here's how the rotation works with a zigzag pattern. Then I set up the polygon colliders for them. This is how the enemy ended up working out. With the jetstream created, I played around with an inverted version of the jetstream trap that would pull the player instead of pushing them. After learning how the CFX whirl effect worked, I updated the particle system for my copy of the stream and inverted the direction so the bubbles pull towards a position. Here's how that effect turned out. The base for the pushing stream was a little bit too small, so I worked on designing something that looks like a cone for the strap's cover portion. Then I imported the sprite and generated its physics shape. The pushing streams were designed for the Quetzal trap, so I went back to the first level to set those up. With the level changing, I ensured I could still beat it within 30 seconds without getting hit. The second level will feature the zigzag enemy, so I sketched out a shape with ascending steps where I would place a zigzag enemy. Following the steps of the art pipeline, I started with the blockout stage. The first version of the size felt a bit small, since you could reach the start and end in 13 seconds. So I tinkered with it until the sizing metrics matched what the rest of the levels of this size match. Next step was to lay out the enemies. The zigzag spikes were fairly easy since the gizmo does most of the work for me. I also added the attractor streams in areas where the zigzag trap would cross them. I included the basic spikes on the floor and ceiling too. Then I played through the level, tweaking the force of the attractors or the positions of the spikes until I could run through it without getting hit. With the shape laid out, I laid out the collider tiles, setting up the tile map and its collider components. I adjusted the traps so they aligned to the collider tiles, since I just set them generally where they should be in the blockout stage. Now that the shape is locked in and the traps are aligned, I added the filler portions of the tile map. With the art complete, as always, I ran through the level as fast as I could without getting hit. Here's a high-level overview of this level. Part of the feedback received mentioned that quitting the game felt too abrupt. This reminded me of the old binding of B to quit the game, which frustrated players. Using the knowledge I gained from watching a Christina Creates Game video on UI anchors, I set to work on creating a panel to hold my menu buttons. Learning from the pains of having to localize things after the fact, I ensured these buttons and the header had localization strings. For better usability, I made sure the menu consistently hides the confirmation dialog if you switch tabs. Since the navigation for the buttons used auto navigation, you could end up navigating to a button that's not selectable. I swapped that to explicit navigation to avoid those problems. Then I had to propagate these to the level selection map, which uses its own copy of the general panel. I also had to replicate that on the main menu since it has a dedicated quit button. When I first made the levels, I only added enough tiles on the maps based on how far the player could see. Now that the camera size increased, I had to go back and update all of those. I used to move the player when doing this before, but I didn't want to accidentally change where they started. To avoid that, I created a prefab object with the same dimensions as the camera's viewport and used that as a reference for how far tiles should go. While fixing these mounts, I noticed that I had left some players in the wrong spot in certain levels, so I also corrected that. The shipwreck levels were the easiest to fix, since they were designed to let you see past the edges into the water. The first version of the game only had an oxygen meter, which also counted as your life. A hit would decrease your oxygen by 10, so I gave a player 30 extra seconds to account for 3 hits. Feedback around the oxygen limit pointed out that it felt like it didn't matter, since you always had more than enough. Since I want oxygen to force players to go fast and play a little reckless, I decided for the first pass to remove that 30-second buffer. I tried the 6th level in the shipwreck world just to see how it felt without those extra 30 seconds, since the larger levels feel the most pressuring. That extra 30-second buffer being gone definitely added to the tension in the last 10 seconds. Then I played through a few of the 2 chest levels to ensure it still was enough. I could complete them in under 40 seconds, so perhaps there's room for these to be a baseline of 45 seconds instead of 60. Data from the first playtest also shows a potential average of 45 seconds for players that have mastered the game. I also tried another 3 chest level and was able to complete it comfortably within 30 seconds. This oxygen change feels okay as a baseline, but I am open to the idea of oxygen varying by level and not just based on the chest count. With oxygen being lower, I took the same style of effect for the last life and applied it to the oxygen bar. For now, the blink effect will occur when there's 10 seconds left, and blink at a faster rate to hopefully increase attention. That's it for this devlog. My focus for the next part will be finish the levels in the 4th world, work through some of the playtest feedback items. If you want to support me, please visit the Don't Drown store page linked in the description and add the game to your wishlist. Until next time.